Welcome to the introduction of exponential and logarithmic functions. Let's get started. So an exponential graph has a little x in the exponent. Okay, so anytime that x is in the exponent, you've got an exponential graph. Now, it has a key point at 0, 1. Most of the other functions we did had a key point at the origin. So here's 0, 1, and this is what the graph looks like. So it has a curve right here to the left that gets really close to this 0, but it never crosses it. It'll go on forever, getting closer and closer without crossing it. Now those are called asymptotes, remember. So this one is a horizontal asymptote at y equals 0. And then the right side of this graph shoots up exponentially. It moves over to the right, it just moves slowly, but it goes up really fast. So if you're trying to read your graph from left to right, the x values, your domain, it goes from negative infinity to eventually it'll get to positive infinity. And your range, reading the y values from bottom to top, it doesn't even start existing until this 0, until it hits 0. And because it doesn't ever actually touch 0, but it gets really close to 0, you have this parentheses. And then it goes, of course, up to infinity. Now, the logarithmic function, and this is a base right here. If there is no base, then it's just assume that it's a 10. And we'll work with other base numbers later. But its key point is at 1, 0. So here is this key point, and this graph, if you were to graph it, let's see if I can draw that a little bit better. It looks like this. It curves 1 back and gets really close to that 0 line without ever crossing it. And it also goes up, it just goes up really slowly. So a logarithmic function has a vertical asymptote. So there's that line that it never crosses. But instead of a horizontal one, like the exponential, it has a vertical. At x equals 0. Now, your domain is going to be 0 to infinity. Because if you're reading from left to right, it starts at the 0 without ever actually touching it. So you have that parentheses. And your range is negative infinity to positive infinity. Now, if you look, these graphs are inverses of each other. They're reflected over this y equals x line. See, so this key point, 0, 1, the inverse of this point is the key point of your log, 1, 0. And the reflections of each other. A horizontal asymptote, y equals 0. It's got an inverse asymptote at x equals 0 over here. The domain of the exponential is the same as the range of the log, whereas the range of the exponential is the same as the domain of the log. So exponential and logarithmic functions are inverse functions. So to summarize that up really quickly, your exponential function has a horizontal asymptote at y equals 0. Its domain is all real numbers, or negative infinity to positive infinity, and the range is 0 to infinity. Don't forget that that's a parentheses and not a bracket around that 0. Whereas your logarithmic function, it has a vertical asymptote at x equals 0. Your domain is 0 to infinity with that parentheses, and your range is all real numbers, or negative infinity to positive infinity. And exponential functions are inverse functions, which we said and we looked at on the first slide, because their graphs are reflected over the line y equals x, which is the parent linear function. So that means if you have a point AB on the exponential graph, then on the logarithmic graph, it must be point BA, because all you do is you switch just like that key point was 0, 1 on the exponential, but on the log, it's 1, 0. Now, we can use exponential functions to solve logarithmic equations, just like we can use logarithmic functions to solve exponential equations, which we'll do in this unit. Now, when we want to transform these functions, here's your exponential, and this is what number 1 looks like on your paper. It's at the point 0, 1, and it curves back 1. Let's see if I can draw that better. So there's that 0, 1 point, and it curves back 1 like this. Remember, that's the asymptote, it never actually touches. So if you want to transform this, 10x plus 3, and then the other one you have is 10 to the x plus 3, so this isn't an exponent, but this is not. And we have 10 to the x plus 3 plus 3. So what this is going back to your h and k. If you remember from other units, we've got an h and k in A. Your h is always with the x, and then your k is out at the end. Your A tells you if it's stretched, compressed, or reflected. Your H gives you your horizontal shift, which means it tells you if it moves left or right, and you always, always change the sign of your H. Your K, you keep the sign of your H. You keep the sign of your K, and it tells you how to move up or down. So that's going to be the same thing here. We've always worked with the H, and we've always worked with the Ks. So the H is always with the X. So my H here is 3. I changed the sign, so my H is negative 3. So the only thing that this function is doing now is moving to the left 3. So I start at my 0, 1, and I move left 3, which is right here. It still curves up, and then it still curves back down 1. So that's what that function looks like. And my asymptote is still at y equals 0, because see, it didn't change. Now if I wanted to move with this, there is no h, but there is a k. My k is 3. So I start at my point 0, 1, I move up 3. And then that curves up, and then the left side of your graph curves down 1 to that line, which is actually 3. So my horizontal asymptote is at y equals 3. Now this one, you've got an h and a k. So my h is negative 3 because we changed that sign. My k is a positive 3 because we keep that sign. So that means it's moving left 3 and up 3. And again, we follow the same curve of the graph. So my horizontal asymptote is at y equals 3. All right, number 2 on your page is about logarithmic functions now. So now we want to transform that log graph that we looked at before. Now it's still going to have the same a, h, and k as the exponential. The h is with the x, tells you how it moves left or right, and you change the sign. And the k is still the number at the end all alone. It tells you how you move up or down, and you keep the sign. And of course the a tells us if it's stretched, compressed, or reflected. So your graph, your key point is at 1, 0. And it curves back 1. And that's not very good. But it curves back 1. There you go, to that vertical asymptote at y equals 0. I'm sorry, at x equals 0. So if you start off on the first one, log x plus 4, you only have an h. We change the sign so it's negative 4. So you move from this key point 1, 0, left 4. 1, 2, 3, 4. You curve back 1. So this right here is your vertical asymptote, and it's at 1, 2, 3, 4, negative 4. So there's your vertical asymptote equation. Now your second one has log of x plus 4. So the k is what you have. So that means we're moving up 4. 1, 2, 3, 4. Same curve of your graph, curves back 1. And that leaves your vertical asymptote at x equals 0. And the last one has an h and a k. It's got this right here is your h, and we change the sign, that's negative 4. And then it's got a plus 4 at the end, so that's your k. So it's going to move left 4 and up 4, right there. And then it curves back 1, and that's your vertical asymptote at x equals negative 4. So go ahead and try numbers 3 and 4 on your own, and practice finding your h and k, and then moving from that original key point. And don't forget to write your asymptote equation for each one. That's all for now. Thanks for watching, and see you soon.